professionals together from around the world to share their insights. And we are delighted to have you with us today. And we trust that you will find this event both informative and inspiring. So, first, I'd like to introduce myself. I'm Varsha, DFIR specialist and foreign event management team member of Hebesec Technologies India. So today I will be hosting this webinar today. And now I would like to welcome our special guest, Dr. Joseph Santoso, Director of STEKOM University, Indonesia. And I also like to welcome today's speaker, Mr. Arunkumar, Security Researcher, Hebesec Technologies, India, and Yashwanth, R&D Developer, Cyber Thulir, Malaysia, and Migunani, M.Kom, Head of Information System Department, STEKOM Indonesia. And also I would like to welcome our honorable guest and audience today. Before this session starts, I would like to inform that today's session will be live streamed on STEKOM University's YouTube channel. For today's event, we will begin with the Indonesian national anthem, followed by the next session. After that, we will move on to the main presentation by a honorable speaker, and then continue after that. After that, we will move on to the main presentation with a question and session. Finally, we will close the program with our group photo for a documentation. So first, we will sing our national anthem, and Mr. Abdul, you can start. Thank you. Thank you. We will go to the main event for our audience. If you have any questions for the speaker, please type them in the chat or raise your hands. We will address some of the questions directly after each presenter has finished. And today's session, each presenter will have a 30 minutes to present. Now, let us warmly welcome our first presenter, Mr. Arunkumar, Security Researcher at Hebesec Technologies, India. The stage is yours.
Hello, am I audible?
Yes, sure.
Good morning. Good afternoon. Myself Arunkumar, Security Researcher at Hebesec Technologies. Today I will present on a topic, AIOps, how AI transform IT operations. These presentations will explain how artificial intelligence is reshaping IT operations, moving organization move reactive management to proactive the predictive strategies. Okay. In this session, first I will introduce our concept of the AIOps and explain its importance. I will describe the innovations of the IT operations from the manual process to the automation and final to AI-driven the management. After that, I will explain the core component of the AIOps and the highlights of the critical role of the machine learning. I will continue by discuss the how AIOps support in automations, integrate the management and the predictive analytics. Next, I will outline the challenges organization face when the adoption AIOps. I will share real world case studies and explain how success can measure using the key performance indication. Finally, I will describe the future of the IT operations and conclude the session will key takeaway. Okay. Next, evolution of the IT operations. In early stage of the IT operation, term really manual process, they only react to the issues after they occur, will often left to the frequent downtime, increased operational cost, and user dissatisfaction. In introduction of the automation tool reduce repetitive tasks and improve efficiency, but the tool still requires human oversight and decision. Today, we are in the era of the AIOps with the artificial intelligence and machine learning. IT operations are beginning predictive and proactive. Systems can now detect anomalies, learn patterns, and even resolve the problem before they affected business services. This shift represent a move from the firefighting problems. After they appear, they prevent them they occur. Okay, go to next slide. Okay. In AIOps build a four key components. The first is a data collection and injections, where the large volume of logs, matrix, event, and trace gathered from across IT systems. The second is artificial intelligence and machine learning analytics, where they identify the pattern, detect the anomalies, and they establish the correlations in the data. The third is intelligent automations, where the system taking the automation action to fix the prevent issues. The fourth is collaboration and visualization, where the insight and display through the dashboard and the report the help terms better a better decision. Together, these components are the continuous loop and collect the data or analysis. It's automated response and provide feedback and continuous improvement. Okay. In the machine learning is the intelligent layer of the AIOps. It's learned what normal system behavior look like analyze the historical and the real-time data. Once it establishes the baseline, it can detect the anomalies. Immediately, machine learning also correlated event across the difficult systems, transform the thousands of the individual alert into a few meaningful insights. This capacity enable its term to identify the root causes of the issues quickly. Without the machine learning, teams would spend a hour or days analyze the raw data within the machine learning. They receive the actionable inside the minute, shifting IT from the reactive firefighting to proactive problem prevention. AIOps enhance the individual management in several ways. It reduces the alert noise by the correlations, relationship alert, and presenting them single incident. It performs the automated triangle by a running diagonalist, collecting logs and pinpointing they like root causes. For the recursing or known issues, AI hopes preventing the self-healing capacity, such as restart service, roll back the facilities update, or selling resource automatically. It also integrating within the IT service management platform to create a ticket, enrich with the necessary context, ensure the route of the correct teams, approach a short-term resolution time, reduce manual effort and improve overall service reliability. Predictive analytics. AI works provided the predictive analytics that the forecast issues before they occur. By analyze both the historical data and the real-time information, it can anticipate capacity shortages, hardware degradation, and the performing slowdown. For example, AIOps form that the server will run on a disk space in a 2 days or the network in approaching the conscious, conscious pointing. This advantage warm gives its a term opportunities to take preventing the action. Pre- Predicting the analytics therefore transform IT operation for the reactive model that represent that problem, arise the proactive the model, prevent issues from the occurring in a first place. But let's talk about the challenges. While the AIOps bring the significant benefits, organization other face the challenges during the adoption. Legacy systems generate data in driven format that are the difficult to integrate to modern platform. Some older system lagging the modern API will the limited data exchange and automation. Cultural resistance is another factor. As a team, may worry about the automation replace the job or may hesitating to adopt a new tools. Security and compliance are also pose challenges. Yeah, as AOps process large amount of the sensitive operational data that must protect the overall these issues, organization need a proper planning, training, and the changing management. With the understanding AOps designed to support people, not replace them. Okay, this is an real world case studies. Several industries has already seen the measuring results from the AO. In the telecommunication, AO reduce the outage of the third sorry 30% of the automatically resolve the half of the incident. In a financial service, AOs cut alert noise by a 80% and the improve mean time resolved by a 25%. In e-commerce, predict the analytic prevent the downtime during the peak sale events, ensure the smooth custom experience and the protecting revenue. These case studies demonstrate that the AOps in not just a theory concept, but the practical solution delivering the real business volume. Uh, this is a measuring success. The success AOps can a measuring through clear the perform indicator, mean time to resolve the improve by more than 13%. Help in terms resolve the problem fast alert noise is reduced by the over 70%, allowing the staff on focus on a critical issues. Outages are reduced to a less 55%, preventing cost downtime operational cost, saving the existing 15% of result, fewer manual interviews or optional resource users. Productive increase by more than a 20% as team shift their attention, the routine firefighting to the innovation and the strategic innovations. These results providing strong evidence of the return to the investing in a AIOps. Okay. Let's talk about the future of the IT operation. The future of the IT operation will be shaped by a collaborating between humans and the artificial intelligence. artificial intelligence will continue to handle monitoring, anomaly detection, and automated responses. Human professions will be remain responsible for the complex problem solving, ethical decision making, and long term strategies. This partnership will ensure the IT system remain the efficient, re- uh, uh, secure, will a human experts drive the innovation and a business growth. The future is not a replace people with the machines, but about using the AI sense human capacities. Okay. In the conclusion, AI represent the major transformations in a IT operation. It reduces the downtime, prevent outages, lower cost, and improve the production by the combining the artificial intelligence, machine learning, automation, and predicting on analytics. AIOps enhance the organization to the move the reactive the response to proactive the prevention management. Although adoption may involve the challenges, the benefit already evidence across industries such as telecommunication, financial, and e-commerce. The future of the operation lies the cooperation between the human and the AI, where the technology handle repetitive work and the human focus on the innovation. Okay, let's finishing our section. Thank you.
Thank you so much for your presentation. And our participants, and we have 3 questions from the participants. Um, I hope there is no questions here, so we can go to the next speaker. And I would like to welcome a second speaker, Mr. Yashwanth, R&D developer, Cyber Thulir, Malaysia.
Hello everyone. Hope the screen is visible, right?
Yes, sir, everything is visible.
Okay. Hello everyone. Good morning, good afternoon, or good evening, depending on where you are joining from. I hope you guys are doing well. My name is Yashwanth, and I'm working as a research and development developer at Cybertolip, which is a cybersecurity focused startup. It's a pleasure and an honor for me to here today, presenting on an international webinar and sharing some insights with all of you. So let's start the session. Today, I will be taking about a very interesting and important topic, AI ops. Um, how AI is automating IT operations. Um, Now, just to give you a short description, before we dive deep, AI ops, which stands for artificial intelligence for IT operations, is all about applying AI, machine learning, and big data to manage and automate IT operations instead of depending purely on humans to analyze logs or troubleshoot problems. AI can process massive data in real time and also detect issues and even solve them before impact users. That's the power of AI, and that's what we all explore today. Um, Let me show the table of contents. Hmm. Before we get started, let me quickly walk you through the structure of today's session. We will begin with an introduction of AIOps, followed by why AIOps is important in today's IT landscape. Then we will talk about the key technologies behind AIOps, and after that, the core functions of AIOps. Next, we will dive into the benefits of using AIOps. but also balance that with a discussion on the challenge and limitations. Then move on to the real world applications, followed by a case study of how a large e-commerce company used AIOps successfully. After that, we will explore the future of AIOps, then wrap up with a conclusion and summary. And finally, we'll have a Q&A sessions too. So now that you know the flow, let's get into the topic. Introduction to AIOps. AIOps, or Artificial Intelligence for IT Operations, was a term coined by Gartner back in 2017. You can think of it as the combination of AI and machine learning with IT operations. Traditionally, IT operations teams had to deal with endless logs, alerts, performance data. Uh, it was not only time consuming, but also overwhelming, and mistakes were bound to happen. AIOps changes this by bringing automation into the picture. It's like having a super intelligent assistant that continuously monitors everything, identifies patterns, detects anomalies, and in some cases, even fix issues automatically. Mm, The idea is to reduce manual work, increase efficiency, and make IT operations smarter. Like you guys already know, the amount of data being generated today is massive from apps, IoT devices, servers, users, and you name it. Handling that manually is just not possible anymore. That's why AIOps has become such a game changer. And why AIOps is important? Uh, The IT world today is more complex than ever. We are dealing with hybrid clouds, distributed systems, microservices, mobile apps, and millions of users interacting in real time. Each of them generates tons of data. Traditionally, monitoring tools are reactive. They tell you when someone has already gone wrong. For example, a website may crash and then the system raises an alert. But by then, the customer is already impacted. uh, AIOps flips this around. It enables real-time monitoring and proactive action. Instead of waiting for something to break, it detects unusual activity earlier, predicts possible failures, and even takes corrective actions before users are affected. This shift from reactive to proactive operations is why AIOps is so critical today. And let's go into the key technologies of AIOps. So what makes AIOps possible? It's powered by a few key technologies. Uh, First is artificial intelligence and machine learning. These allow systems to learn from past data and improve over time. For instance, if a server crashes every time a certain pattern of traffic happens, the AI learns that and warns you in advance. Second, we have big data analytics. As I said before, IT system generates massive amounts of data. Big data tools process this information in real time, so nothing slips through. Then we have the natural language processing (NLP). This is what helps AIOps to read logs, reports, and messages just like a human would, and interpret them intelligently. Finally, we have automation and predictive analytics. Automation handles routine repetitive tasks without human help, while yeah, while predictive analytics forecast possible issues so they can be prevented before they happen. When you combine all these technologies, you get a system that is faster, smarter, and more reliable. And let's dive to the next slide. Yeah, core functions of AOP. Let's look at the AOP's actual does it practice. Okay, the first core function is continuous monitoring. AOPS keeps an eye on your servers, network applications, basically your entire IT environment 24 by 7. The second is event correlation. In a big IT setup, you might get thousands of alerts in a single day. Most of them are unrelated. AIOps groups related alerts together and show you the bigger picture. It's like connecting dots to find out. which alerts or symptoms of the same root problem. This alone saves the IT a huge amount of time because they don't have to choose false alarm anymore. And the next functions, let's go to the benefits of AIOps. So, what are the benefits? The biggest is speed. AIOps enables faster incident detection and resolution. Instead of waiting for IT staff to wake you up at 2 a.m. and fix something, the system can either solve it or at least alert the right person immediately. It also reduces downtime. Like you guys already know, downtime is very costly. For big companies like Amazon, even in a few minutes of downtime can mean millions in losses. And another benefit in automation of repetitive tasks, things like restarting servers, balancing loads, clearing logs, all of that can be automated. And AIOps can also boost IT teams' productivity. When routine work is automated, teams can focus on higher value activities like innovation, security improvements, and system upgrades. It also supports proactive decision making because AIOps generates real time insights. Leaders don't have to wait for monthly reports. They can act instantly. And finally, it saves costs by preventing outages and minimizing services disruptions. AIOps reduces both direct financial losses and hidden costs like customer dissatisfaction. And challenges and limitations. Of course, like any technologies, AIOps are also challenges and limitations too. The first is cost. Setting up AIOps solutions requires investment, and not all companies can afford it. The second is integration with legacy systems. Many companies still run on outdated technologies, and connecting them with modern AIOps tools can be complex. Third, there are data privacy, security concerns. Since AIOps works with large volumes of sensitive data, ensuring its protection is critical. And finally, there's the skill gap. You need to professional who understand both IT and operations on of AI. That combination is rare, so trained and expertise is crucial. And let's get to the real world applications of AI. So where do we actually see AI being applied? Um, in cloud management, it ensures resources are optimized and systems stay on. In application performance monitoring, it detects slowdowns before users are affected. In cybersecurity, it identifies suspicious activities and anomalies in real time, helping to prevent breaches. In help desk, it automates ticket disclassification and even resolves common issues without human help. And in network monitoring, AIOps predicts outages, balances traffic, and ensures smooth connectivity. As you can see, it's not just theory. AIOps is just being used in real organizations today. And as I said before, let's learn about that case study. Uh, Let me give you a concentrate example. A large e-commerce company was struggling with frequent payment gateway failures, especially during big sales events like Black Friday. Customers were frustrated and the revenue was being lost. They implemented AIOps, and here's what happened. They achieved 40% reduction in downtime during peak hours. Payment failures were detected instantly. Root cause analysis became much faster, reducing manual troubleshooting, and most importantly, customer satisfaction improved because issues were solved before customers were even noticed. This shows that real value of AI. It's not just being about just technology. It's about improving customer experience and business outcome. And the future of AI. Looking ahead, the future of AIOps looks very promising. We are heading towards self-healing systems that can detect, diagnose, and even fix issues without human intervention. Imagine that IT systems fixing themselves automatically. We also see closer integrations with the DevOps and cloud native tools, making IT operations more agile and efficient. And as regulations grow stricter, AI-driven governance will help organizations stay compliant with security and data protection standards. So, in the future, AIOps won't just be an add-on. It will be the backbone of IT operations. And as a conclusion, to conclude, let's quickly summarize what we have covered today. AIOps stands for Artificial Intelligence for IT Operations, and it's applying AI and ML and big data to manage IT systems more efficiently. We discussed why it's important in today's complex digital world, the technologies behind it, and the key functions it performs and the benefits of it offers. We also looked at some challenges, real world applications, and a case study showing how an e-commerce company reduced downtime by 40%. And finally, we saw how the future of AIOps is moving towards self-healing intelligence IT systems. So, in short, AIOps transform IT from being reactive and manual to being proactive, automated, and intelligent. And thank you so much for giving me this opportunity to present on such an important topic at this international webinar. If you have any questions, please feel free to drop them in the chat box and I will be happy to answer. Once again, thank you for your time and attention. It's been a pleasure sharing this with you all. Thank you.
Thank you so much for your presenting, Mr. Yashwanth. And you have a question from a participant. I will be dictated. The question is, can AIOps completely replace human IT operators, or is it more about argumentation?
Can you repeat that?
Yes, I will repeat it. Can AIOps completely replace human IT operations, or is it more about argumentation?
Great question. AI isn't designed to completely replace human IT operators, at least not in the foreseeable future. Instead, it's best understood as an augmentation of human capabilities. Uh, Noise reduction and correlation automatically filters alerts, finds patterns, and correlates events across systems. Anomaly detection. What about anomaly detection? Spots unusual patterns in logs, metrics, and or traces that humans might miss. Root cause of analysis (RCA) suggests likely causes by analyzing massive data set faster than humans. Predictive insights like anticipates outages or performance degradation before they occur. And finally, automated remediation in some cases can trigger scripts or workflows to fix recurring issues. What humans still excel at is contextual understanding, complex decision making, and ethical accountability, continuous adaptation. The final is, in short, AIOps doesn't replace human; it makes them super operators. Hope you understand. Thank you. Any other questions?
No, sir. Thank you.
Thank you. Thank you.
And I would like to call upon the final speaker, Mr. Migunani, M.Kom, Head of Information System Department, STEKOM University.
Okay, thank you. Good afternoon for all audience who I respect. Greeting to all our participants and also the honorable all students and all audience. May I first take this occasion to pay tribute to all of the audience of the international webinar event with the title is AIOps, Integrating AI and Machine Learning into IT Operation. I'm very happy I can open today's presentation in front of all of you. In the next 30 minutes, I will explain about topic of AIOps, integrating AI and machine learning into IT operation. I will share for my presentation. Okay, my presentation looks like Varsha.
Yeah, sure.
Okay, thank you. AIOps, wait. AIOps marks a paradigm shift in the IT operation, defined by the strategic integration of AI and machine learning. It revolutionized how we manage systems by automating monitoring, accelerating incident resolution, and continuously optimizing performance. The result? Enhanced efficiency, rock-solid reliability, and smarter and faster IT operation. AIOps operates through three interconnected components that work in harmony to transform IT operations. First, data ingestion and integration converges diverse data sources like logs, metrics, event, and trace into a unified real-time view of the IT environment. This breaks down silos and create a comprehensive operational picture. Next, data processing and analysis leverage advanced AI and machine learning algorithm to mine this unified data. Here, pattern emerge, anomalies are detected, and actionable insights are extracted, turning raw data into intelligence. Finally, this insightful automated decision making and action. The system trigger precise responses, generating contextual alerts, executing self-healing remediation procedure, or dynamically adjusting system configuration, all without human intervention. This closed-loop cycle integrate, analyze, act, enable AI ops to continuously optimize performance, predict failure, and maintain operational resilience at machine speeds. IOP and ICOP faces several critical components. In IOP's closed-loop system, monitoring or observe serves as the foundational sensor layer, continuously scanning the entire IT ecosystem to detect anomaly and pattern before the impact users. This component perform real-time data collection and analysis across every layer of infrastructure, application, network, cloud environment, and IT devices. By engaging diverse signal, metric, log, trace, and event, it creates a living pulse of the operational environment. The primary objectives are threefold. First, full visibility. We capture signal from all sources, eliminating blind spots. This unified observability ensures no critical data point, whether a CPU spike, like log error, or network latency, gets unattested. Second, early detection. By analyzing the signal in real time, we identify emerging issues before the affect users. Think of it as a digital immune system that spots threats at their inception. Third, context. Monitoring is just about collecting data. It's about understanding relationship. Through dependency mapping and correlation, we grasp how components interact. For example, linking a database latency spike to a recent application update. In the next, ultimately, monitoring or observes transform raw data into actionable intelligence, providing the comprehensive real-time awareness needed to trigger the next phase, intelligent analyze and respond. The power of the monitoring puzzle, AIOps leverage a specialized toolkit of technologies designed for comprehensive visibility. The first, observability tool like Prometheus, Grafana, Datadog, and Dynatrace capture real-time metric and performance data, turning raw number into visual dashboard that reveal system health at a glance. Second, log management solution such ALK stack, aggregate, parse, and index unstructured log data. They transform millions of log entry into searchable insight, letting us point error or security event across any time frame. And third, distributed tracing tool like a Jaeger and OpenTelemetry track request us the hop between microservices. They map the entire journey of transaction, exposing bottleneck in complex and distributed architecture. But how do this tool work together in practice? Let's look at two real-world examples. For example, one, correlating database latency with application error. Imagine Prometheus detect a sudden spike in database response time. Simultaneously, the ALK stack flags a surge in application error logs. By correlating the signal in Grafana, we instantly see the connection. The database slowdown is causing application timeouts. This unified view lets us intervene before users are affected. Example 2, mapping service dependencies. Using Jaeger, we trace a customer checkout request. Is it moves from the front-end API to the payment service and inventory system. When the inventory service fails, distributed tracing visualize the ripple effect. Payment retreat, spike, and then front-end experience delay. This dependency map help us isolate the root cause and prioritize fixes. In essence, this technology doesn't just collect data. They weave disparate signal into a coherent story, enabling AIOps to detect issues early and understand their full context. In AIOps closed-loop system, service desk engage act as the critical collaboration hub where human expertise and AI intelligence converge. It serves as the interaction interface connection at IT team and user and the AIOps platform, transforming raw AI insight into validated context-aware action. This component fulfills three primary objectives. First, human AI collaboration. It creates a symbiotic partnership where human provides strategic oversight while AI delivers speed and scale. Think of it as an expert co-pilot. AI surface data-driven recommendation, while human contribute experience, institution, and business judgment. Second, business contact. This is where we bridge the gap between technical signal and real-world impact. User and IT team inject crucial non-technical information, like app X is running a flash sale, so traffic spikes are expected, or system Y support critical financial supporting, so prioritize its stability. This context prevents AI from making technically correct but but operationally flawed decision. Third, decision validation. It implements the essential human in the loop safeguard before executing automated action like restarting a production server or scaling results. The system present recommendation to human for approval or rejection. This ensure critical decision align with business prioritize and risk tolerance. For example, when AIOps detect an unusual spike in payment processing error, it might recommend restart payment service. But through the service desk interface, the team adds context where processing and of quarter viral delay action until 5 p.m. Then the AI then adjusts its response, preventing disruption during a critical business window. Ultimately, service desk engage transform AI from black box automation system into a trusted partner, ensuring AI action are not just fast but strategically sound and contextually intelligent. To power the service desk engaged page, AIOps integrate three key technology categories that enable seamless human-AI collaboration. The first, ITSM tool like ServiceNow, Jira Service Management, and Zendesk from the backbone of the structured workflow. They transform raw AI recommendation into trackable tickets, ensuring every action is audited, prioritized, and aligned with IT governance framework. Second, ChatOps leverage Slack of Microsoft Teams, both to enable real-time conversational interaction, imagine, and engineer typing. AIOps bot typing why is a payment API slow and instantly receiving a correlated analysis of metric, logs, and recent deployment. This turns complex troubleshooting into a natural dialogue. Third, knowledge-based integration connect platform like Confluent or Wikis to tap into instant institutional memory. When issue arise, IAOps automatically sources historical solution, past incident response, run books or troubleshooting guides to suggest proven resolution step. But how do this technology converts in practice? Let's explore two implementation example. For example, one is automated approval workflow. When IOP detect a failing container in generate a recommendation, restart container Y to resolve memory leaks. Instead of manual ticket creation, the system send this directly to the Slack channel. Then IT team review the context, approve with a simple white check mark reaction, and the action execute instantly, reducing resolution time from hours to seconds. Example 2, intelligent solution sorting. User report, mobile checkout is failing. AIOps immediately cross-reference their error with the knowledge base. It finds three similar incidents, one resolved by clearance case, another linked to a recent API update, and third requiring a database restart. The system present this ranked option to the support team based on historical pattern. Try case clearance first. In essence, this technology creates dynamic interface where AI provides speed and scale, while a human contributes context and validation, turning this effort desk into a strategic command center for IT operation. In IOPS closed loop system, automation or X serve is the execution agent. translating insights from monitoring and service desk into immediate, precise action that resolve issues without human intervention or with minimal approach. This component transform lies into outcome at machine speed. The core purpose of automation or ACT is threefold. First, rapid resolution. Its less mean time or to resolution or MTTR from hours to second, where traditional IT operation might take hours to diagnose and fix a problem. IEL execute pre-authorized remediation action instantly, like restarting a service, scaling resource, or applying a configuration patch. Second, consistency. By codifying best practice into automated workflow, it eliminates human error in repetitive tasks. Every action follow a standardized tested procedure, whether it's a clearing a case, rolling back deployment, or blocking a malicious IP address, ensuring reliable outcome every time. And the third one is scalability. It handles thousands of incidents simultaneously during peak traffic or system-wide event. Automation or X orchestrates parallel responses across distributed environment, maintaining stability even under massive load. For example, when monitoring detect a critical database connection pull exhaustion, automation doesn't wait for human intervention. It instantly executes a pre-approved sequence, scale database instant, restart connection pool, and notify stakeholder, all within seconds. Similarly, if a service desk validation validates security threat like a brute for attack, automation immediately enforce firewall rules, isolate compromised account, and trigger forensic analysis containing the threat before it escalated. Ultimately, automation turned AI from a diagnostic tool into a self-healing system. Well, issues are resolved as fast as they detected, freeing human team to focus on innovation rather than firefighting. To power the automation in ActPulse, AIOps leverage three categories of technology that transform insight into immediately executable action. The first one, orchestration tool like Ansible, Terraform, and Kubernetes operator manage infrastructure and application lifecycle. The codify operational procedure into reusable version control playbooks, enabling consistent deployment, scaling, and configuration across hybrid environment. The second one is a workflow automation platform, such as Komoda and Apache Airflow, sequence complex multi-step processes. They chain together individual action like API calls, script execution, and human approvals into intelligent workflow that adapt to changing condition. And the third one is self-healing script, written in Python, PowerShell, or Bash, provide granular remediation capability. This purpose will script execute targeted fixes, auto-scaling VM virtual machine during a traffic spike, restarting unresponsive service, or applying security patches in real time. Now, let's see this technology in action through two implementation example. The example one is proactive disk space management. When monitoring detect a server disk at 95% capacity, automation immediately trigger a self-healing script. This script identify and delete temporary file older than 7 days. Then send a cleanup report to the service desk, all within seconds. This prevents application phases before they occur. An example two is intelligent database optimization. When the service desk receive user report, database is slow during peak hour. Automation execute a multi-step workflow. Run a diagnostic query to identify fragmented indexes. Two, applies optimization command via Ansible playbook. Three, restart the database service. Four, validates performance improvement. And five, notifies stakeholder of resolution. This entire sequence completes autonomously, restoring optimal performance in under 2 minutes. In essence, this technology creates a self-healing fabric where issues are resolved as fast as the detected, turning IT operation from reactive firefighting into proactive self-optimizing system. I hope it's continuous self-improving closed-loop system where four interconnected components work in harmony to transfer IT operation from reactive to autonomous. Let's walk through this intelligence cycle. First, observe the system nervous system. This component continuously monitor your entire infrastructure, application, network, flow service, and IoT device, acting as the eyes and ears of your IT environment. IT detect anomalies, performance deviation, and potentially issue in real time. What is the output? The output is anomaly data, rich, contextualized, now about what's happening in your ecosystem. This data flow directly to the next parser, is engaged. In the next parser is engaged, the human AI collaboration hub. Here, the system interface with human through service desk or chatbot. It takes the anomaly data from observes and enrich it, it with two critical elements. This is a business context, like this is a big retail season, and human validation is approving or refining AI recommendation. What is the output? The output is context and validation. Actionable intelligence that marries technical insight with a real world prioritize. This flow to the execution phase is act. And the next execution phase is act, the self-healing engine. This is where automation come to life. Act execute precise remediation action, auto-scaling resource, restarting service, or applying configuration change based on validated insight from engage. But it doesn't stop there. Act produce two vital output. The number one is action result, and number two is model update. Action result, data confirming whether the fix succeeded or failed, which loop back to observe for verification. And the model update, performance data sent to the AI or ML engine to improve future decision. And number four is AI or ML engine, the learning core. This is the brain of the operation. It processes outcome from acts, both success and failure, to refine algorithm and retrain model using real-world data. What is the output? The output enhanced detection capabilities, smarter, more accurate anomaly detection that feedback into observe, making the entire system more intelligent with every cycle. The cycle in action. Imagine a sudden spike in payment processing error. Observe detect the anomaly and flag it, engage, add context. This is during a flash sale. Approve auto-scaling. X, scale payment servers, and confirm success. EIML engine learn the flash sale require three times more resource and update detection rule. This create a flywheel effect. Each cycle make the system faster, smarter, and more autonomous, ultimately having self-healing IT operation that continuously optimize themselves. This IOP cycle represents a transformative operational flow that convert raw observability data into intelligent automated action. While continuously involved through feedback-driven learning, four interconnected principles make this possible. The first one, closed-loop automation creates a self-improving system where its execution feedback into the next cycle. Like a living organism, it learns from every action. Successes reinforce effective response, while failure refine future decision. This creates a flywheel effect where the system grows progressively smarter and more autonomous with every incident. Second, human in the loop provides a critical validation at the engaged stage, ensuring safe automation. Rather than removing human, IAOps strategically position them as governors, approving sensitive action, providing business contact, and overriding AI when necessary. This hybrid approach balances machine learning with human wisdom, preventing automation from becoming a liability. And the third is continuous learning power the AI or ML engine evolution with each action result. Every remediation, whether successful or not, become training data. The system analyze outcome, updating algorithm, and refine detection rule in the real time. This means yesterday failure become today improve response, creating a constantly maturing operational intelligence. And the fourth, real-time adaptation leverage to the feedback loop to enable immediate response to changing condition. When infrastructure patterns shift, like sudden traffic spike or new failure models, the system instantly adjusts its detection threshold and remediation strategy. These dynamic responses turn IT operation from reactive firefighting into proactive self-regulating management. In the next is the synergy in action. Imagine a cloud service experiencing unprecedented load during a product launch. The cycle activate instantly. Observe, detect the anomaly, engage, validate auto-scaling, human approve, execute resource provisioning. AI and ML engine learn the new load pattern. Within minutes, the system has not only resolved the issue, but also update its baseline understanding of normal, making it better prepared for a future event. This is how IAOps transform IT operation, creating a self-optimization ecosystem where automation is safe, learning is continuous, adaptation is immediately, and each cycle makes the system more resilient the last. DevOps and IOps represent two transformative paradigms in IT operation. It's addressing different layers of operation excellence. Let's break down their focus and output. The first one is DevOps, the foundation of collaboration and automation. It is a core DevOps breakdown silo between development and operation through three pillars. There is collaboration, automation, and integration. It creates a unified workflow where code moves seamlessly from development to production. The primary output of DevOps are velocity and stability. Velocity is accelerating future delivery, enabling them to deploy update multiple times per day instead of a week or month. And stability is reducing downtime through automated testing, infrastructure as code, and consistent deployment pipelines, ensuring system remain resilient even amid a rapid change. The second one is AIOps. AIOps is the evolution to intelligent operation, where DevOps optimize how we build and deploy. AIOps leverage AI and machine learning to automate decision making within IT operation itself. It built on the DevOps foundation, but adds cognitive capabilities. The primary output of IOPS are proactive management and autonomy. Proactive management is shifting from reactive firefighting to anticipating problem before they impact user, like predicting a storage failure or traffic bottleneck hour in advance. And the second one is autonomy. Autonomy is creating self-repairing system that automatically diagnose, remediate, and optimize such auto-scaling results during a traffic spike or restarting failed services without human intervention. What is the synergy? How to connect? Think of a DevOps building a high-speed railway, velocity and stability, where IOPS adds the intelligence signaling system that is proactive and autonomous. DevOps ensure we can deploy change quickly and safety, and then IOPS ensure the system then run, heal, and optimize themselves. For example, DevOps automated deploying a new payment feature, AIOps monitoring the future post-launch, detect an unusually latency pattern, predict potential crash, and auto-scale resource, all while learning to prevent similar issues next time. Together, they create a future where IT operations aren't just fast and reliable. They are self-aware, self-healing, and continuous improving. Well, DevOps and IO both transform IT operation. They address fundamentally different layer or operation maturity. Let's break down their distinction across five critical dimensions. The first one is focus. DevOps center on collaboration and process automation between development and operation team. It's about breaking silo and streamline workflow. And IOps evolves this focusing on automated decision making using AI. It shifts from process efficiency to cognitive intelligence. And the second one is data. DevOps prioritize pipeline metric like a deployment frequency, lead time and mean time recovery, MTTR, and data measure workflow efficiency. But IAOps demand observability data, log, trace, event, and metric to understand system behavior. Data fuels AI-driven insights. And the third one is automation. DevOps automates task-based action like deploying code, running tests, or backing up system. It's about what and how to execute. But IAOps enable cognitive automation like correlating event, predicting failures, or prescribing solution. It's automates why and when to act. And the fourth one is final goal. DevOps aim for delivery speed and stability, releasing feature faster while maintaining uptime. And IO pursues system autonomy and zero-touch operation, self-healing system that require minimal human intervention. And the fifth one is human role. In DevOps, engineers control the pipeline. They design, monitor, and intervene in workflow. But in AIOps, engineer monitor the AI. They offer recommendation, validate action, and refine algorithm, acting as a governor rather than operator. AIOps is a replacement for DevOps. It is a strategy evolution that builds upon and amplifies DevOps foundation. Let me clarify the symbiotic relationship. DevOps as the essential foundation. IEOps stand on the shoulder of DevOps, relying on three critical pillars: infrastructure automation, the codified infrastructure management that default established become the playground for IEOps intelligence. And the next is CI or CD pipeline. The automated deployment workflow DevOps perfected provide the execution framework for IOPS action. And the next is observability. The monitoring culture in DevOps embedded become the data source that fuels IOPS algorithm. Without this DevOps foundation, IOPS would lack the structure, automated environment needed to operate effectively. IOPS as an intelligent enhancer. Well, DevOps automated processes, AIOps automated decision, adding a cognitive layer that elevate operation to new level of sophistication. And DevOps automated rollback if deployment is failed, reactive safety net. AIOps predict deployment failure before execution, a proactive shield that prevent failure from occurring. The evolution in action. Consider a typical deployment scenario. DevOps build automated pipeline, then run test, stage code, and deploys the production. If error occur, if auto rollback, IOPS enhance this by analyzing historical data, current system state, and environmental factor to predict. This deployment has 87% probability of causing database timeout. It then either recommend, change, or auto-adjust configuration before deployment. What is the synergy create a resilient? The synergy of create a resilient DevOps give us the speed and stability to deploy change rapidly and safely. But IOPS adds the foresight to make those deployments smarter and more resilient. Together, they create a self-improving system. Well, DevOps handle the whole of automation. IOPS handle the way and when of intelligent action. This is an replacement. It's a reinforcement. DevOps build the high performance engine. IOPS add the intelligent navigation system that anticipate roadblock before they appear. Well, IOPS represent a powerful evolution beyond the DevOps. Organization face for critical challenge when making this transition. Understanding this hurdles is essential for successful implementation. The number one is data quality. This is the foundation challenge. AIOps demand clean, structured, and consistent data to function effectively. Requirement often unattainable in early stage DevOps environment. Many organizations struggle with data silo, inconsistent format, and incomplete context. This is a three. Many organizations struggle with it. Data silo is a critical information trapped in disconnected system. Inconsistent format like log, metric, and traffic following the different standard. And incomplete context is missing metadata that links even to business impact. Example, an IOPS platform can predict database failure in 40%, offload entries are unstructured or missing timestamp. And the second one is skill gap, the talent evolution. Team must expand beyond DevOps expertise to master ML and data scientists. Significant upscaling challenge, new competencies, cross-disciplinary demand, training investment. New competencies like data engineering, model training, and algorithm evaluation. Cross-disciplinary demand like a professional who understand both IT operation and AI or ML. And training investment is a significant time and resource needed to upskill existing staff. For example, DevOps engineer skilled in Kubernetes might lack this statistical knowledge to evaluate anomaly detection model. In the third one is a trust issue. This is a explainability barrier. Accepting AI recommendation without transparency remain a fundamental challenge. The first one is black box problem, and the next is accountability concern and validation requirement. Black box problem, team resists acting on recommendation they don't understand, and accountability concern, who responsible when AI-driven action cause incident, and validation requirement is need for human verification that undermines automation benefits. For example, an AIOps system recommend restart all payment service during peak hour, but operator hesitate without understanding a way. And the fourth one is integration. This is the toolchain complexity. Combining them all, toolchain with AIOps platform create architecture and operational complexity like compatibility issue, workflow disruption, and maintenance overhead. Complexibility issues is a legacy system resisting modern AI platform. And workflow disruption like integrating IEO decision into existing CI or CD pipeline in machine learning. And maintenance overhead, that is managing additional layer on technology and dependencies. For example, connecting Jenkins deployment with ML flow model monitoring requires custom development and ongoing maintenance. Okay, thank you. This is my presentation. Time is yours.
Predictive analytics play in AIOps for preventing IT failures? Can I repeat the question, sir?
Okay, the question is, had role do predictive analytics play in IEOps for preventing IT failures? That is the questions. Okay, predictive analytics is the cornerstone. Predictive analytics is the cornerstone of proactive IOps, transforming IT operation from reactive firefighting to strategic failure prevention. Here is a detailed breakdown of its role, mechanism, and impact. Predictive analytics uses historical data, ML algorithm, and real-time telemetry to forecast potential failure before they occur. It shifts IT operation from what went wrong to what will go wrong and how do we stop it. Key function, the first one is failure forecasting. Mechanism for failure forecasting is time series model like LSTM, analyze metric like CPU or memory usage, disk I/O, or network latency to predict degradation. For example, forecasting hard drive failure in 72 hours in advance using smart attribute in hard disk. And the second one is anomaly anticipation. A mechanism to anomaly anticipation is unsupervised learning. For example, isolation forest, autoencoder to detect subtle deviation from normal behavior pattern. For example, flagging unusual memory leaks in a Kubernetes cluster before they crash pods. And the next is capacity planning. In the capacity planning mechanism, use a regression model, predict resource exhaustion. Database connection will hit 90% in 6 hours, for example. Auto-scaling cloud resource during a product launch to prevent slowdowns. And the fourth is causal inference. The causal inference mechanism is use the Bayesian network or graph-based model identify roots cause of predictive failure. For example, latency spike will occur due to a misconfigured load balance in the network. For example, preventing cascade failure in microservices by pinpointing dependency risk in the network. Okay, this is answer for the question. Thank you.
Thank you, sir. And thank you to the speakers who shared their knowledge in a way. And it's time for documentation. As we near the end of this webinar, let's immortalize this moment with a group photo. And please activate your cameras and wear your best smile. I'll count down to capture the moment. And Mr. Abdul, please capture the moment. 3, 2, 1. And one more for the group pressure. 3, 2, 1. Thank you all for your participants, and this photo will be a good moment for everyone. And it's time to end up everything. And as we conclude this international webinar, let us reflect on the knowledge, connection, and insights we are sharing today. We sincerely thank our distinguished speakers, the organizing team, and all enthusiastic participants for your active engagement and contributions. This event highlights the power of global collaborations and the potential of technology to connect with us abroad and everything. May the ideas and discussions from today inspire your future and endeavors and partnerships. Let's stay connected, continue the conversation, and work together towards a bright future. Thank you once again for being a part of this webinar, and we look forward to welcome you to upcoming events. Until then, take care. Have a nice day. Thank you.
Okay, thank you, Varsha. Thank